Okay, so for this section, we're going to talk about something called determinants, and we're going to talk about two different types that we can find because they're the most common. What determinants are used for is eventually we can use them to help us solve like a system of equations. So if you're given two equations that have an x and a y, both of them involved, we can use a determinant of either something with two variables or three variables to help us solve for whatever those values would be. So whether you've got like x and y, and we want to figure out what x and y should equal so that the equations balance out, then we can do that. So we're going to start with a 2 by 2 matrix because the 2 by 2 determinants are a little bit easier than the 3 by 3 in just that they don't require us to do as much work. So when you see a 2 by 2 determinant, it's going to look a little bit different than the matrix does. Remember, the matrix had like those kind of square-ish brackets around the outside. So they had those hard edges, but they kind of went in a little bit around the numbers. When we see a determinant, you're going to have just straight up and down bars. They almost look like absolute value bars. So it looks like you've got absolute value of this whole array of numbers. And when you see that, they're telling you to find the determinant instead of like adding or subtracting or multiplying your matrices together. When you want to find the determinant of a 2 by 2 matrix, you use kind of this setup, what I'm highlighting right here. So if you look at the elements that are inside of a 2 by 2, that means that you have two rows and two columns. So we call them A, B, C, D, just to represent that they could be any numbers out there. And when I do this, what I'm basically doing is cross multiplying and subtracting in the middle. So I'm taking A times the D and C times the B, and then I'm subtracting those two products. And that's going to give me the determinant. So for example, in this first one, I have 2, 3, 1, 6. I'm going to cross multiply. So I'm going to take 2 times 6, and I'm going to subtract 1 times 3. So I'm just kind of following what I have up there, that A, D minus CB. So 2 times 6 is 12, and 1 times 3 is 3. So I'm having 12 minus 3 here, which is going to give me an answer of 9. So when we're doing determinants today, we're looking for a singular number to be our answer. I'm not looking for a new matrix. I'm not looking for a new array of numbers. I just want one single number, like 9. Okay, so you guys try number 2. When you do this one, be careful of the negative signs there, because you're taking 4 times 7, which is 28. You're subtracting negative 3 times 2, which would be negative 6. So you're going to end up adding those two numbers together, and you should have gotten 34 for your final answer. Okay? So that's a 2 by 2. Pretty easy. Cross, multiply, subtract. Now when you start getting into 3 by 3 determinants instead, there's two methods that we can use. I'm going to show you how to do both of them. Okay, it's a little bit more of a process because we have more elements. Okay, just like when we were multiplying matrices, we had to do that process where we took rows times columns, and the bigger the matrices, the more multiplication we had to do, the more combining those rows and columns we had to do for those problems. For determinants on 3 by 3 matrices, there's one method that's called expansion by minors, and there's another one called the diagonal method. I'm going to show you how to do both so that you're familiar with both. If you're given the option to choose, you can choose whichever method you like better. Some kids like the minors method better, and some like the diagonal method better. When you're given a 3 by 3 matrix, you're going to see all of those terms are labeled like A1, A2, A3, B1, B2, B3, C1, C2, C3. So those places are going to stay true for all of these determinants. Now when I do expansion by minors, so the first one, what I'm ending up doing is kind of breaking it down so that I end up doing determinants of 2 by 2 matrices because that's easier because they're smaller. And if you just kind of look, it's got like this is the equation right here that you're basically going to follow. As long as you can match up from your array of numbers, which one's the A1, which one's the B1, which one's the C1, you just have to plug it in, and then you just have to start doing the math. So for this one, you'll see you've got 3 2x2 determinants in there. So you'll have to do what we were just doing, cross, multiply, and subtract. And then you'll have to multiply by the term that's in the front, the A1, the A2, and the A3. Be really careful that you watch the signs. This one has a minus sign, and this one has a plus sign. So just make sure that when you're writing it down, you don't skip over, you don't put the wrong sign down in the wrong spot. Now the diagonal method, a little bit different. So if you look at how they have it written, they have the same like array of numbers, the A1, B1, C1, all the way down to A3, B3, C3. All that's the same. But what they do is they add on 2 extra columns. And it's the first 2 rows repeated. So you're just going to grab those first 2, not rows, columns. You're going to grab those first 2 columns and just write them right next to the determinant. So then what we do is we look at our diagonals. So the diagonals are going to be A1, B2, C3, B1, C2, A3, and C1, A2, B3. So what I just highlighted there in yellow, that's one set of diagonals. And that's what they have written down first. So all of these 3 right here with the plus signs, that's the first set of diagonals. Now the second set of diagonals, we start at the bottom right or the bottom left corner with that A3 term, and we go diagonally the other way. So the other 3 diagonals are going to be over on this side. And you'll notice that those last 3, they all have minus signs in front of them. So again, when you're doing either method here, be really careful, be really aware of the signs that they have in there, because in some places there's plus and sometimes there's minus. And so you got to make sure that you have the right sign in the right spot. So I'm going to show you examples of both. We're actually going to start with the diagonal method. So if we turn the page over, we're going to find the determinant by using the diagonal method for this one. And then I'm going to give you guys one that you can try using just the diagonal method. So the first thing I would do is take the first 2 columns from your determinant and copy them down right next to the edge of that determinant there. So that means you're going to put 2, -5, -4 down, 1, 6, and 3. Okay, I'm going to do my first set of diagonals. So I start with 2, which is that top left corner, and I go diagonal down to the right. So 2, 6, 1, then 1, 0, -4, 7, -5, and 3. So those numbers that are on the diagonal, I'm multiplying them. So I'm going to take 2 times 6 times 1, and then we have a plus sign. 1 times 0 times -4, another plus sign, 7 times -5 times 3. Now we're going to switch our diagonals. So now I'm starting with the -4 in the bottom left-hand corner, and I'm going up to the right. So what I highlighted in green there, there's my second set of diagonals. Now for these next set, we start with a minus sign in front of all of them. So -4 times 6 times 7 minus 3 times 0 times 2 minus 1 times -5 times 1. Okay, at this point, I would multiply the numbers that are inside the parentheses before you try to add or subtract anything. So 2 times 6 times 1 is going to be 12, plus, this is going to be a 0 for the second one because you got a 0 in there, plus 7 times -5 is -35, and then times 3 is going to be -105. Then we have minus, in here you have -4 times 6 times 7, which is -168, Then we're going to have minus 0, because again, we're multiplying by 0 with that 3 and that 2. And then the last one here, we have minus a negative 5. So I would watch your signs here because we've got some negatives, we've got some double negatives happening. So what I'm going to do is just kind of simplify this a little bit. I've got 12 plus 0, which is just 12. I'm going to rewrite this so it says minus 105 plus 168. That minus 0 is not going to do anything, but I do have a double negative in front of the 5, so that makes it plus 5. Okay, at this point, you can just go ahead and subtract and add. So you can take 12 minus 105 plus 168 plus 5. You should end up with 80 as the final answer there. Okay, so that's the diagonal method. I want you guys to try the second one on that page there using the same method that I just used. So draw those diagonals in, multiply the numbers, and then watch your signs, add and subtract at the right spots. Okay, so I've got my numbers, my first two columns rewritten. I've drew in my diagonals. I've written out what you should have been multiplying together. So for this, we get 0 plus 12 plus 0 minus 0 minus 36 minus 0. You got quite a few zeros for this one. Okay, anytime that you guys see a 0 in there, it's always going to be 0. So that makes that math really easy. To simplify here, I would have 12 minus 36, which is going to be negative 24. Okay, so what we're going to do on the next page is we're going to do expansion by minors, but if you take a look at those matrices, or those determinants, they are the same numbers as the two problems on the previous page were. Okay, that means that we already know what the answer should be, because we've already done them using the diagonal method. We're going to use the expansion by minors now, so I can show you that method as well. But like I said, for this first one, we know from the previous page that it was 80, so I should know I should get an answer of 80 for this problem. If I don't, then I'm doing something wrong. Okay, and the same is going to happen for number 2. So for the minors one, this is when we want to use this equation up here that I have boxed in the green. Okay, so I'm going to go ahead and first just set it up by following what they wrote up here. So I'm just going to kind of think about where's the A1, the B2, C through all of those pieces, and just start setting up my problem so that it matches this, and then we'll start doing the math. Okay, so for this one here, remember it goes A1 across the top, it goes A1, B1, C1, and then the middle would be A2, B2, C2, and so on. So for that first one, you start with the A1 term that sits out front, so that's going to be a 2. And then we're doing a 2 by 2 determinant, and it's the B2, C2, B3, C3. So that's like the bottom right corner. So 6, 0, 3, 1. Okay, then we have a minus sign. Then we have the A2 term, which would be the number right underneath that 2, which is that -5. And then inside of that determinant, for that 2 by 2, we're using B1, C1, which would be the top 2, the 1 and the 7, and the B3, C3. So you're kind of skipping over that 6, 0 in the middle. So 1, 7, 3, 1. And then for the last one, we have a plus sign, and that's in front of your A3 term, which is a -4. And for that determinant, we're doing B1, C1, B2, C2. So it's like the top right-hand side of that determinant. So the 1, 7, 6, 0. So the determinants kind of have a pattern to them, and just that the first one we use the bottom right-hand side, the last one we use the top left-hand side, and in the middle one you kind of cut out that middle 6, 0. So when you're trying to find a way to remember how to set these up, you can always look for some of those patterns again, because it's going to be the same for all of these matrices that we do. All right, now for those 2 by 2 determinants, remember all we're doing here is we're cross multiplying and we're subtracting in the middle. So this first one will have 2, and then inside we'll have 6 times 0 minus 3 times, 6 times 1, 3 times 0. So 6 times 1 minus 3 times 0. For this second one, because I see the minus a negative here, I'm going to go ahead and change that to a plus sign. I don't like double signs, so I'm going to eliminate them as soon as I can. And then in there, we're going to have 1 times 1 minus 3 times 7. And then we have plus a -4, so I'm just going to write that as -4. 1 times 0 minus 6 times 7. All right, so taking this a step further, we're going to have 2 times 6 minus 0 plus 5 times 1 minus 21 minus 4 times 0 minus 42. All right, so we have 2 times 6 plus 5 times -20 minus 4 times -42. So this is going to be 12 minus 100 and then plus 168. So if I do this, 12 minus 100 plus 168, if you want to double check that, you should get 80, just like we did on the previous page. So I want you guys to try the second one. And like I said, the second one is the same as the second one was on that previous page. So you already should know what the answer is going to be because we did it earlier. So I want you guys to try to set it up and see if you can get your answer to match. Okay, so I'm kind of writing mine out here. At the very end, I got negative 36 plus 0 plus 12, which does come out to be that negative 24 like we found on the previous page.